Welcome back. We'll now try to see what trigonometric identity we can come up with if we start off with cosine of alpha plus beta. Cosine of alpha plus beta. Let's see if we can rewrite this as another combination of cosines and sines of alpha and beta. So let's get started. And if you've already watched the sine equivalent of this, this proof will be pretty similar in how we operate, and we get a kind of similar answer. And something interesting is just to kind of compare the difference between sine of alpha plus beta and cosine of alpha plus beta after we're done. So just like that last proof, let's say that this angle, now that color isn't bright enough. Let's see, let's do yellow. Let's say that this angle right here is alpha, and this angle right here is beta. Right? So alpha, we want to know cosine of alpha plus beta. So alpha plus beta is this large angle right here. Right? So what's the cosine of that? SOHCAHTOA. So cosine is adjacent over hypotenuse, right? SOHCAHTOA. A8. Let me see. SOHCAHTOA. So cosine is equal to adjacent over hypotenuse. So for this large angle, what's the adjacent? It's line AC. So that equals line AC, that's the adjacent, line AC, the length of line AC, over the length of line, what's the hypotenuse? AB, right? All right, AC over AB. Now let's see what we can do with this. AC, adjacent over hypotenuse. Now, can we write AC in any other interesting way, a combination of some of the other lines on this very fortunately designed graph? Let's see. Well, isn't AC the same thing as AF, this big line? AF minus, what is this? This is a D, right? Okay, that's a D. It looks almost like a, let me rewrite that as a D. D as in dog. There you go. So AF minus DE, right? Because this, oh, I forgot to draw some things. We assume that this line is perpendicular to that line. We assume this line is perpendicular to that line. We assume that line is perpendicular to that line. Right? And by definition, that is because we drew it that way. But anyway, so now you know that this line is parallel to this line. So we can and this line is perpendicular. So we know that AF, this long line, minus DE, is equal to AC. Does that make sense? AF, this big one, this big line, AF minus the shorter line is the same thing as AC, right? So let me write that down. That equals AF minus DE, all of that over AB. All of that over AB. And then, of course, we can rewrite that as, and I'm going to switch to some different colors. We can rewrite that as AF over AB. Right? And we switch to maybe green. Minus DE over AB. So we have now AF over AB minus DE over AB. And those are kind of nonsensical ratios to me. Wouldn't it be great if we could express it somehow as AF over AE? Because then we could, say, well, that's cosine of alpha, and do something from there. Well, let's try. So let's rewrite this first expression. So I'll switch back to the purple just so you know where this first expression is coming from. Let's see if we can break this down as AF over AE times something else. Well, we can just algebraically do it. That's equivalent to AF over, I might run out of space, over AE times AE over AB. You're saying, Sal, where did you get that from? Well, you could kind of say my motivation was to have AF as a ratio of over AE, and I just, I just set it up so that the multiplication would cancel out because the A's would cancel out, and you'd be left with AF over AB, right? So this is a reasonable thing to do. I hope you see. So, and then let me switch to the green and do something similar. DE over AB. DE over AB doesn't make much sense, but if I could maybe do DE over BE, then I might be, if this angle I can see is, is similar to alpha or beta, then maybe I can make some progress. So let's say DE over BE times, and we'll do the same thing. You just have to multiply BE times BE over AB. And just like in that sine proof, and we'll do the same thing here. So let's figure out what this angle up here is, right? Because if we know that, then these ratios become useful. So if this angle is alpha, then we know that this angle right here is alpha, right? Because DE, because this line is parallel to AF. You learned that in geometry. And if this angle is alpha, we know that this angle right here is 90 minus alpha, because it's complementary, right? Because this whole angle is 90 degrees, so this is 90 minus alpha. And since this angle, 90 minus alpha, this angle 90, and this angle add up to 180, we can figure out that this is alpha. And if you don't believe me, add up alpha plus 90 minus alpha, and you will get 180 degrees. So this angle up here, angle DBE, is alpha. So that's very interesting. So can we rewrite these ratios as the sines or cosines of alphas or betas? Well, let's try. Let me switch back to purple. So that equals, what is AF over AE? AF over AE. Well, if we look at this right triangle, that's the adjacent over the hypotenuse for alpha, right? Adjacent over hypotenuse, that's cosine. So it's cosine of alpha. Cosine of alpha. And what's AE over AB? AE over AB. Well, they're similar. It's if we look at this big right triangle right here, that is the adjacent over the hypotenuse for beta. So that's cosine of beta. Cosine of beta. Switch my colors. Minus DE over BE. DE over BE. Well, this is alpha, right? A little smudge. You probably can't read it, but that was alpha. We showed that was alpha. So DE is the opposite, and BE is the hypotenuse. So opposite over hypotenuse is sine, right? So that's sine of alpha. Sine of alpha. And what is BE over AB? BE over AB. Look at this triangle again. Well, for beta, that is BE is the opposite, and AB is the hypotenuse. So opposite over hypotenuse for beta. So it's the sine of beta times the sine of beta. I'm running out of space. I have to go to another line. Sine of beta. Pretty neat. So we have now learned. I'll rewrite everything in a new and exciting color. The color selection is difficult. Oh boy, what am I doing? Okay, let me do it in light blue. So we now know that the cosine of alpha plus beta is equal to the cosine of both of them multiplied. So cosine of alpha, cosine of beta, not cob, cosine of beta, minus the sine of both of them multiplied, minus sine of alpha times sine of beta. I hope you found that as satisfying as I do. See you in the next presentation.